Welcome to part 3 of our mini lectures on stoichiometry and stoichiometry problems. In this episode, we are going to do a mass-to-mass problem. So I would like to go through and just again model for you and demonstrate how to use the factor label box in order to solve these different problems. So whenever you have a problem, the very first thing that you want to do is read the problem and determine what you're given and what you're looking for. So in this case, it says how many grams of the tin-2-fluoride are produced from the reaction of 30 grams of HF with tin. So I'm going to go back in. It says how many grams of the tin-2, so I'm going to put a little grams is equal to question mark, that's what I'm looking for, is produced from the reaction of 30 grams of the HF. So I'm going to put 30 grams of the HF. All right, so the next thing I want to do after I've written down what I'm given and what I'm going to be looking for is I want to go through and balance my equation. So I'm going to look up here. I have one SN, one SN, one H, two H's. So I'm going to have to put a 2 right here. When I put that 2 here, that gives me 2 hydrogens on this side, 2 hydrogens on this side, 2 fluorines, and everything is balanced. So now I've balanced my reaction. I want to now go back up to my original stoichiometry road map, and now you have your own road map so you can be following along. It says starting at grams, which is going to be mass. So I'm going to put a little asterisk right there so that we know where we're starting. I'm looking for grams, so I'm going to come all the way over on this side. So as you can see, I'm not starting at moles anymore. I'm starting way over here. I always go from left to right. So I'm going to go from mass to moles. Then I'm going to do a mole to mole ratio, and then I'm going to go from moles to mass. Always remember, anything that is on this side to the left is going to be my first substance, and in this case, it's the HF. And anything from here over is going to be my second substance, what I'm looking for. In this case, it is the SNF2. So write down what you're given in a factor label box. So I have 30.0 grams of HF. I want to put that in a factor label box. The very first thing that I want to do is I want to go from grams to moles. So if I'm going to moles, I'm going to write the word mole down. The gram goes on the bottom because that's what I'm going to have to factor out. Then I just simply say, what's the relationship between a gram and a mole? And of course, we know that to be the molar mass. So the molar mass is the number of grams in this particular formula. So I'm going to come over here and I'm going to say, all right, if I have a hydrogen, that's 1.01, and a fluorine, I'm going to have to look on my periodic table, is 19.0. So I'm going to put 19.0. So when I add this up, I actually get from the molar mass of the HF is going to be 20.0 grams per 1 mole. So guys, the grams are going to cancel out. Now I'm left with the number of moles. So I've moved from here to here. So my next step, and this is, I'm going to continue my factor label box, is going to be my mole to mole ratio. So I just simply do that. I write moles on the top, moles on the bottom. I'm not worried about numbers yet. I first want to get my mole to mole ratio of what I'm looking for. In this case, what I'm looking for is SNF2. And what I'm factoring out is going to be the HF. So now I can go back in and say, okay, using my balanced equation, I have a 1 and a 2, and that is going to factor out the moles of HF. At this point, I am now at the moles of my second substance, which is the tin-2-fluoride. I'm not asked for moles, I'm asked for grams, so I have to take it one more step. Grams over moles. So now I'm going to have to come back and use the formula SNF2 to determine the number of grams per 1 mole. So I'm going to say SN, and SN is going to have 118.7. So I'm going to put 118.7. I have 2 of the fluorines. We said fluorine was 19.0. So 2 of those is going to be 38.0. So when I add these 2 together, I get a 7, 16, 156.7 grams per 1 mole. So I'm going to put 156.7 grams per 1 mole. So guys, I just set it up so that all I have to do now is to take everything is in the numerator, the 30 times 1 times 1 times 156.7, divide it by what's in the numerator, which is 20 times 2. So you got to be careful. Make sure that you follow the order of operations. So 30 times 156.7 is going to be a total of 4,701. I'm going to divide that by 40, and I get 117.5 grams of my 10,2 fluoride. I like that. Nice and easy, straightforward. So I follow my stoichiometry road map from mass all the way across. I would like to go ahead and model for you the next problem as well. It says, what mass of aluminum, so I'm looking for the mass of my aluminum, is produced by the decomposition of 50 grams of the aluminum oxide. So over here I have 50 grams. So I've written down what I was given. The next thing I want to do is balance my equation. So this is a decomposition. So it's going to balance with a 1, 2, 3, or 4 right here. The 1 doesn't work because I got a 3 and a 2, and there's nothing I can multiply 2 by to get 3. So I'm going to put a 2 right here. So now that gives me 4 aluminums and 6 oxygens. So it balances with a 2, a 4, and a 3. 2, 4, and 3. Go back up, use my stoichiometry road map, and I hope y'all see that I do the exact same thing every single time. Doesn't matter what the problem is, I'm still going to come back up. I'm going to start at this time at mass, and I'm going to go to mass, which means that I'm going to go mass to moles, mole to mole ratio, moles to mass to finish out. So write down what I'm given, which is 50.0 grams of aluminum, Al oxide. I put that into my factor label box. I'm going to first convert that to a mole. So I have to get the molar mass of the aluminum oxide. So I know that I have aluminum, which is 2 times, and my aluminum is going to be 27. So 2 times 27.0 is going to be 54.0. Then I have 3 oxygens times 16.0 is 48.0. So I'm going to get a total of 102.0 grams per 1 mole. So we're just going to put that in, 102.0 grams per 1 mole. So guys, I just went from mass to moles. My next is going to be a mole to mole ratio. So I'm going to draw that out, and I'm just going to write in mole to mole ratio. Again, no numbers, no anything. Now, I always, 100% of the time, doesn't matter what I'm doing, I always put what I'm looking for on the top. This time it's going to be aluminum. What I'm factoring out on the bottom, which is my aluminum oxide. So now I come back to my balanced equation. That's a 4 over here and a 2 over there. So now I have just went to the number of moles. The last step is to go from moles to grams. So I'm going to put a gram right here and a mole. This time it is the molar mass of just an aluminum, which is 27.0 per 1 mole. So guys, I am ready to calculate my answer. So when I calculate my answer, I'm going to say 50 times 4 times 27. 50 times 4 times 27. And then I'm going to divide that by the 102 times 2. 102 times 2. And I did put that in parentheses, and I come up with an answer of 26.5 grams of aluminum. So, last thing is, I set this up and I call it a mass-to-mass problem, but what it actually means is I'm going from the far left all the way over to the far right. I do not have to start with grams. I could have started with the number of particles and had to use Avogadro's number to get to moles. Or I could have started with the volume of a gas and used at STP and used 22.4 liters per 1 mole. So I can do anywhere on this side, and I can go to anywhere on this side. So I hope that that has helped by putting our notes into 3 different parts. Part 1 was a mole-to-mole problem. Part 2 was a mole-to-mass problem. And now Part 3 is a mass-to-mass problem. I hope that'll make it easier for you to go back in and look up and figure out how to do them if you're having any problems. Thank you.